Okay, so now I will add a small correction to the Matlab video of the Gauss elimination method. In fact, I realized some of your colleagues realized that there was a problem in the video concerning the backward elimination part. So I will do the backward elimination part, and I will just go through the forward elimination once more. So forward elimination was is straightforward. What we did is basically we eliminate the equation at each step from the subsequent equations. Okay, so this is how we proceed. And now we have completed the forward elimination. Now let's write end of forward elimination, just to define that the forward elimination part is ended. Now I will put here a back substitution. Now the point is this: I already begin from the end equation, and I will go through the first equation. In fact, it's quite straightforward. I can easily find the xn here. So xn is equal to, now, or just put a breakpoint and let me show you something. Just run it. Okay, so let's change the folder. So we will begin by calculating the last variable. In fact, let's write xn here. So xn is equal to bn divided by a n n, and let's put a breakpoint here and check whether everything is okay. So I have my B's here, I have my A here, upper triangular matrix, and then as you see, I can easily calculate the value for the Bn. So B is minus 2.5, N is 3, it's 999, and continue. Yes, okay, it's minus 0.0025. Now the point is, I will apply a backward substitution. Therefore, for I1 is equal to N2, 1 with minus 1, and let's check whether it will work. I think this is minus 1 and 2, 1, because I don't remember how it, yeah, it's okay. Do loop is okay. Now I will continue with the back substitution, and so this is, now I will modify this line with the n minus 1, and I will gather from I1 to I1 plus 1 to n, and this will be multiplied with x values. So when it is 2, it is 3, 3 to 3, and this will be multiplied by 3. Yes, that's okay. 2, 3. This is minus EI, and this will be divided by A I1 I1. And this is equal to XI 1. Okay, this will give us the values. Let's check. So I have to calculate the transpose of it. Transpose of the X matrix, because X is a row matrix now. This is why it gave me an error. Now X is calculated. And as a result, I have X values. I can say that X is equal to transpose of X. Now I can check the error. Error is equal to A times X minus B. I entered the wrong code. It's transpose here. You see, error is 0. So I find the correct inverse. Now I will do pivoting. So remember that I do the partial pivoting. Now for the partial pivoting, I changed the places of the equations, which are larger than the pivot equation. So I look at the complete set at each step. So let's say that I have for I is equal to 1 to I want to n, and this is end here. Okay. Now I will look for the specific column. This is I2, by the way. This is I2, and this is from I1 to N. Now I will take the absolute value of it. Okay. Now I take the absolute value of it. Now next step is finding the location of the maximum. I put max here. Okay. Now it will give me the maximum value. For example, let's check whether it will work or not. I will put a continue line here. I will set a breakpoint here. That's okay. You see, when I2 is equal to 1, so the maximum in the first column is maximum of the absolute value is 100. And let's check. Yes, it's 100. It's the second one. So what I'm going to do is very simple. I will just take that line. I will put a dummy variable here. But let's calculate or gather the max value and index is equal to. Now I will exit from the debugging mode and I will run it again. And I will check for the max value is 100 and index is 2. But be careful here, index is the index of this array. So in order to get the correct index has to be modified. So index is equal to index plus I1 minus 1. So let's check it once more. Now it gets the index. There is no for loop. There shouldn't be any for loop for this. Okay, let me check it. This has to, yes. There shouldn't be any for loop. I will just check values below it, and I will just change their places. So this is I1, yes, first column, I1 to N, and that will work. Okay. Then I will have the dummy row, let's say, and for the dummy row I will just check the complete row with the index. That's okay. Now I have the dummy row. I got it to the memory, and I will change the first row, the pivot equation, with the dummy row, which has the maximum value of the index. So A index is equal to A I1 that's okay. Now next, so this is okay, index is A1, and A I1 has to be equal to dummy row. Again, quit. I will put a breakpoint here. It goes to the second line. Index is okay. Now I find the second row as the pivot equation, which has the largest then it goes okay. Now as you see, the first row and the second row, the places of the first row and second row is changed. Now the largest one is the first one, and the second one will be like this. So let's say continue, and let's check the matrix A now. As you see, the first row is eliminated, and I will check for the second one. So in the second row, you see that there is no pivoting is required, and it goes to the error because the iteration is completed. But the point is we have to change the right-hand sides. Also, once we change the left-hand side of the equation, we have to change the right-hand side of the equation. Now I will add something here, dummy variable. Dummy variable will be B index, and I will do the operation. B index is equal to B I1 and B I1 is the dummy variable. So let's check the equation step by step. So this is my first iteration. Now in the first iteration, this is my original matrix, as you see. Certainly the first row and second row has to change their places. Let me continue step by step. I press on the step button. Now you see the first equation, first row and second row has changed their places, and first row and second row also changed their places in the B matrix. This is one thing. And second thing is let's continue for the second iteration. Now the first variables are eliminated. Now I will look for the second line. I will go step by step. Now I1 is 2, as you see, and we don't know the value of index, but index is 1. So I1 is 2, it is 2 to 3 in the second row. Okay, and I will just look at the absolute value, so it gives me 1, and as a result, this is 1, I1 is 2, it is 3 minus 1, it is 2. So dummy index, so index is 2, therefore I will change the place of 2 with 2. Let's check the matrix A. It's okay. I will put a breakpoint here, and I will say continue. Let's check the matrix A. It has to be upper triangular. Yes, it is upper triangular. So first variable is xn. Xn is correctly found. Let's look at the x values. 175 minus 175 and minus 0.0025. and the error is 8 times, oh well, I have to multiply the original matrix A. So I have to define an original matrix. This is why it gives me a non-zero element here. But it doesn't matter. So it gives us the correct value. It is 10 to the power minus 14. So it is 0. Okay. So now I did the pivoting also. Now let's do the scaling. Now, when I look at the scaling, I just look at the values in a row-wise manner. So this is what I can do. I can do the scaling in a dynamic manner, in a static manner, doesn't matter. So I just choose a set of expressions with one row, and then I just look at the maximum of it. Again, I will put a for loop here. Now, I look at the maximum of absolute value of the A in the E2 row. I don't need to let's say that this is maximum value, then I divide the corresponding row with this maximum value, corresponding equation with this maximum value. I put a semicolon here, I put another semicolon here, and I will continue AI1 maximum value. So this is equal to AI1. Now I have to divide the right hand side as well with the same maximum value. This is I2. This has to be I2 too. This is I2. And this is I2 as well. This is VI2, VI, VI, VI. Yes, that's okay. Now it appears to be correct. Now this will give me the scaled equation. Let's check. So the maximum value in each matrix has to be 1. Yes, 1, 1, and 1. No. Let's check it step by step. So I will put a breakpoint here. Okay, this is my original matrix. Now this will normalize my first row. So the maximum value is 13. Let's check. Yes, it is 13. And A is divided by 13, so it becomes 1 for the first row. That's okay. For the second row, it is again 0. It's 100, by the way. Now B will be divided by 13. This gives 1.61. Just a moment, please. Yes, this is first iteration and it goes to the next y. Well, I made a syntax error here. It is column sign. Okay, and so on. Now it should be okay. Didn't get the... Yeah. Let me check A. Yes. The maximum values are properly arranged. Now I will do the pivoting. Just say continue. Okay. So you see the change here error. There was a 10 to the power minus 14 error, but now after the scaling, you got the correct values in a much more accurate manner. So this is how the scaling and pivoting works. So this is the end for the correction of the Matlab for Gauss elimination. So the rest you can find in the previous video.